Hello Quanta friend, I am Tipton here again with another mysterious world in this video that is called the Planck's world. Have you ever read the Alice in the Wonderland? You may have read also the Mowgli story. You have also Santa Claus's country, Santa Claus's land and the Wonderland everywhere. Harry Potter you have read, and probably you have seen that these Wonderland are not actually seen with our 5 traditional sense organs. So this Planck's world, named after the famous scientist Max Planck, is a very important here to note down. Why Planck's world is noted down? The first cause I would like to say that Planck's world is just a world which was created just before the atomic world. You know, wherever we are standing here, it is an earth, and it is a planet called Earth. We are the man, woman, human beings, all other beings around us are there. Everything is made of atom. But this atom was generated by something. In quantum physics it is said that is the Planck's world, where the atoms were getting prepared to be the atom. Atoms were getting prepared to be a full-fledged atom. That is the main thing. Now let us explore what is the Planck's world. Basically, Planck's world is driven with Planck's length, that is small l capital P, Planck's time, small t capital P, and Planck's mass, that is small m capital P. So these 3 quantities which are measurable actually are the basic ground of the Planck's world. What is this Planck's world and what is this Planck's length? We will have to know first to be acquainted with this Planck's world, because I said you it is a mysterious world, the world that was created before the creation of the atom. Planck's length, that is small l and p, is the smallest length in the universe, visible universe and invisible universe also. It is discrete. This length is not a part of any length. If you draw a straight line, you can make different lines from that, cutting here, cutting here, cutting here, cutting here, cutting here, subtly cutting here, again cutting here, infinite time. But Planck's length is such a length which cannot be cut from anywhere. That is the fundamental length. The most small length, smallest length in the universe. How did it come? The question arises here. This Planck's length gives the birth of Planck's time. And Planck's time is also related with the Planck's mass. Now the question what I said you, that how did this Planck's length came? The measurement of Planck's length is 1.62 into 10 to the power minus 35. Can you ever imagine? So small a length? Yes. The so small a length is there, that is the unit or fundamental unit of length which is creating all lengths in the universe, which is creating all the lengths in invisible and visible universe both. This Planck's length 1.62 into 10 to the power minus 35 meter is astoundingly making us wonder that how can it be made? Let us explore. You know that there is a constant called Planck constant, especially in the electromagnetic wave. This Planck's constant is the proportion of the energy and the frequency. In any electromagnetic wave, if you observe any electromagnetic wave, there is a frequency and there is energy. So, the proportion of this energy and frequency is always constant, which is called Planck's constant, and it is denoted by H. So, H is Planck constant. Everywhere you go, this proportion will be constant, in the visible or invisible, wherever universe, wherever you go, this will be constant. But the question is here, if we divide it by 2 pi, it will give you the frequency. angular frequency. It is needed because angular frequency is the most vital fact to measure the spin, measure the momentum, measure the force, measure everything related to it for the particles or the particles which are going to be formed. So h by 2 pi, when it was written, it was observed that whatever research we can go for further in the quantum world, this h by 2 pi is an inevitable quantity. So if we have to use this h by 2 pi everywhere, why not are we making this h by 2 pi equal to something ABCD or something like that, so that our mathematical calculations be easier to represent? So scientist Dirac gave the name h bar. That means h by 2 pi, Planck constant by 2 pi is h bar, which is called reduced Planck constant. This reduced Planck constant is basically the proportions of the frequency and energy divided by 2 pi, which is giving the birth of the angular frequency to get our this Planck's constant from derived from this Planck constant. And here we know that there was a famous equation by Albert Einstein that E equal to mc square. Energy gets converted into totally mass, or mass gets converted into energy if it travels with the speed of light. The speed of light, the maximum speed of light, this universe, according to classical physics, according to Einstein. And this formula is E equal to mc square. Energy equal to mass multiplied by the square of the speed of light. So if we come to this point and if we think that there is something to be brought here to measure this reduced Planck constant, we will pull here the second law of Newton, which says the force of attraction between two bodies is directly proportional with the multiplications of the masses and indirectly proportional with the square of its distance. So this theory gives another constant, that is G. You know, this is gravitational constant. What is the value of this gravitational constant? You will know in this video. Just look and get concentrated into the matter. So there is a gravitational constant, and this gravitational constant is m1 m2 by r square. But we have known that m is totally converted into energy. So here the questions of E and c square comes to substitute this m1 and m2. If we substitute this m1 and m2 with the energy, then we will see that it is clear that h bar is equal to Planck's constant by 2 pi. And so this Planck's length will come from this one. If we substitute m1 m2 divided by r square by the E equal to mc square formula, then h bar multiplied by g divided by c cube, there will come a single length. This length is the smallest length. In any mathematics we have done so far for this observable or invisible universe, we did not find shorter than this length. And astonishingly, this length is still shorter than the radius of a nuclei. So it is proved that when this smallest length comes into the length of the radius of a nuclei, then the matter takes birth. Before it, no matter, no particle, no electron, no proton, no neutron, no quark, no gluon, nothing is there. That is another world. So this Planck length is such a thing, which is the smallest length and discrete. I said earlier, it cannot be divided. It is the smallest length. Now consider, the smallest length is a space, one-dimensional space. If it is an one-dimensional space and if it is discrete, cannot be divided, this fundamental smallest length in the visible and invisible universe can be called a string. String theory takes birth from here. And the theory of everything, that is an effort to make out the relations between gravitational force in one side and strong and weak nuclear force and electromagnetic force on another side is also being prepared here. So this is a wonderful world. And from that formula I said you, which derive the Planck length, if we then try to make out the speed of light there, if we calculate the distance the light covered, time taken to cover that distance, the light will be the smallest unit of time, discrete time. So wonderful factor that smallest length and smallest time has been achieved and they are discrete. So space and time are distinct, they have no connection with each other. So there must be somewhere in this visible or invisible universe where time and space are not attached with each other, and time is like one-dimensional factor, many type of times there. It is not a continuous arrow of time as we observe in our three-dimensional world. So there is another dimension where time is just like a granule and space is just like a granule and it flows as a fluid. Randomly it goes here and there, randomly goes here and there. Time in his own way as a granule are floating and space as a granule are floating. This is the birth of the space and time. So Planck's world is incredible world where the birth of space and time are getting. So I sometimes wonder that we cannot see this world, but our mathematics proves that is there, because mathematics has its own tracer, that is hidden variables. I talked about the I, the complex number, that is also the denotion and reflection of some hidden variables, which may work in our dimensions also, which may work out of our dimension also according to string theory. Sometimes to match with our dimension, we always make I a square. That means root over minus 1 square. When it's getting squared, then it is coming to our three-dimensional spaces and solving a lot of problems. So in other dimension, it is hidden there. So Planck's length, Planck's time, and in the same way, you can get everything. You can get the Planck's mass, the smallest mass in the world. The world, I said not only world, in the universe and visible and invisible universe, everywhere, the smallest mass, which is also lighter than the subatomic particles. The most light subatomic particle is also heavier with this Planck's mass. So Planck's length, Planck's time and Planck's mass is always making a world which is beyond our observation, beyond our five sense organs. I told you, don't think mathematics only a tool of measurement or only a tool of representation. Just observe mathematics as the running commentary of an event. I told you that in the first phase of the origin of this universe, there was nothing, and nothing and everything was superposed there, as zero is not at all zero. It is the superpositions of everything and nothing, existence and non-existence both. Due to quantum fluctuations, this existence is being non-existence and non-existence again being existence. Existence is being non-existence, non-existence means again existence. Everything is being nothing, nothing is being everything. This is the quantum fluctuation, popping out and popping down, popping out and popping down, popping out and popping down in the visible and invisible universe, in a vast area. In this time, when the supersymmetry starts to form, then oscillation starts to grow there, from everything to nothing, making creator and annihilator operator. In my earlier videos, you will get a clear idea about what is annihilator operator, creator operator, and the field operator. Here we can think that the first oscillation which makes this amplitude is the Planck's length. It is giving the birth of a string. So, let me repeat again that whatever I said, the most small length in the universe is Planck length. Most small time in the universe is the Planck's time, and most light mass in the universe is Planck's mass. So Planck's space is created, Planck's time is created, Planck's mass is created. So here the string is created also. So Planck's world is such a world which is living, which is existing in between the quantum world and the classical world, in the way of the string theory. It is going on. But is the mystery ends here? No. There are much more mysteries. The more we'll go into the depth of the quantum physics and string theory with this Planck's world, we will see another things, another world that we cannot observe. So I cannot keep patience. Just wait for my next video and I will come again into this mysterious world, just driving through this Planck's world to another dimensions. Here we knew the birth of the space and time, and so afterward what happens and what mysterious things can come before us, we will be discussing in our next video. Till then, from the 7th Quantum Academy, I am Chiptan, would like to inform you that if you are interested in these videos and online class, you can subscribe our channel 7 Quantum's Academy exclusively for free and tap the bell icon to get notified when the new videos uploaded with the different playlists with different topics and different mysterious subjects. And the last but not the least, if we have to come back again with another mystery, then I will have to go now. So, a little goodbye to you. See you again in next video. I am waiting. Will you wait?